And so this is part 2 of the video on assignment number 2 for unit 7, which is on polynomials. And so this is a good question here, and I want to make sure that you are paying attention as we go through this, because this kind of question is going to be on your homework and your quizzes and upcoming tests. And so we just want to make sure that we know what we're doing here. This is a tough question. So anyway, it's about carry-on luggage, and you know that some carry-on luggage, like maybe this one, you'd have to carry it underneath the plane, but there would be some luggage, maybe this one, you might be able to fit above the compartment in your plane. And so what we want to do is come up with the bag that has the dimensions that's going to give us the biggest bag that we can have as a carry-on bag in a certain airlines. And so there's two stipulations here. The first one says that the length is could be 10 inches longer than the width, and then that the sum of the length, the width, and the height is less than 40 inches. And what we want to do is maximize the volume. But what we know is that the volume is equal to the length times the width times the height. But right now, that's 3 variables. And so what we want to do is come up with an expression for each of, or at least 2 of those variables, so that we can write the expression for the volume in terms of just one of those variables. And so the first thing, excuse me, that we can do is we can write an expression for the length. We know that the length is equal to 10 inches less than the width. And so that's the width plus 10. So this is going to be really helpful for us, because I can go over here to the length and rewrite the length with w plus 10 in its place, just like we do in substitution when we're solving systems. But then I also want to come up with an expression for h. Since this is going to be in terms of w, I want to get the h out of there and write that in terms of w. And if I go with the second sentence here, it says that the sum of the length, which means if I take the length plus the width plus the height, I will get a sum. I could get a sum of 40, and I want to make it as big as I can, so I'm going to make it equal to 40. And what I'm going to do is solve this equation for h. And so if I subtract the L and subtract the W from both sides, I'm going to have that H is equal to 40, but then I'm going to subtract L and I'm going to subtract W so that they're on the right-hand side of the equation. But then what I'm going to do then is replace this L here with W plus 10. So it's going to look something like this. I'll have 40 minus L, but L is W plus 10 minus W. And so now I'm going to go ahead and simplify this expression. I have h equals 40. I'm going to distribute the negative 1 here. That's minus w. Negative 1 times 10 is negative 10 minus w. And then I could simplify my like terms. 40 minus 10 is 30. And a negative w and a negative w is a negative 2w. And just for convenience sake, I'm going to write this like this. I'm going to write it as negative 2w plus 30. All right, so now I have this expression for h, and I have an expression for L, and they're both in terms of W. So what I'm going to do is rewrite this volume equation. Volume is equal to the length, but the length is W plus 10, times the width, which is just W, times the height, which is negative 2W plus 30. And so this is the equation for the volume in factored form. I'm just going to put it in standard form. To do that, I'm going to multiply W plus 10 times W. I'm going to distribute this kind of backwards here. So W times W is going to be W squared, plus W times 10 is 10W. And now I'm going to take that term and multiply it times my last term, which is negative 2W plus 30. So if I FOIL this, I'm going to have W equals W squared times negative 2W is negative 2W to the third. When I take W squared times 30, it's going to be 30W squared. Then 10W times negative 2W is negative 20W squared. And 10W times 30 is 300W. Now I'm going to combine like terms. And so when I do that, I'm going to have negative 2W to the third. And then 30W squared minus 20W squared is plus 10W squared plus 300W. And so this is my equation in standard form. So now I'm going to get my calculator out, and on my calculator, I'm going to turn it on here. You can go to y equals, and you can type that equation in. This is in standard form. I could also put it in factored form, which is this form right here. But I would type it in as negative 2x to the third, there's my w to the third, plus 10x squared plus 300x. And right now, if I go to graph this equation, there's really not going to be a lot that I'm going to be able to see. Because the volume is going to be pretty big. I do know this, if I solve this, there's going to be a 0 at negative 10, which you can kind of see there's something going on right there at negative 10. There's going to be a 0 at 0. Now you cannot see that because it's probably too steep. There's also going to be, if I solve this equation for 0, I would subtract 30 and divide by negative 2, and I think that's 15. So somewhere over here at 15, there's going to be another 0. So I'm going to have to go back and change my window. I'm going to just change my window so it goes from, let's say, negative 20, so I can see everything, to positive 20. And I'm going to count by, let's say, 5s. Oops. I'm going to count by, let me clear that. So I'm going to make it 20, and I'm going to count by 5s. And then I'm going to have my x scale be, I want to see what's going on below the x-axis. I'm going to make it negative 200. I want to put in a pretty big number here. I might have to change this later on, but I'm going to make it 1,000. I guess, let me go back. Let me clear that. I'm going to make it 1,000. And that might be more than 1,000. We'll see here in a little bit. I'm going to make my scale be 100. And so now when I graph this, see what we have. There's negative 10. There's my 0 at 0. And there's my 0 at 15. And so we can kind of see that those are my zeros. I could get that from factored form. I can't really see the bottom of my graph or the top of my graph. I'm going to go back and change my window so it's a little bit lower. Let's make this negative, I don't know, 500. Keep putting in an extra 0. Negative 500. And I'm going to have it go up to, let's say, 2,500. And now when I graph it, all right, still can't see the bottom here, but I can see the top here. It wouldn't make sense. This part of the graph doesn't make sense with the problem because x represents the width, and I can't have a width that's negative. Can you imagine a width of a bag that is negative 6 inches? It just doesn't happen. So this is not really part of the graph that's going to make sense with my situation here. And so I'm interested in this part right here. I have these different volumes. The maximum volume is right here. Remember, y is the volume. So I want to get the maximum volume. I want to find this point. I could just trace this so we can get an idea of what's going on. If my width is 0, my volume is 0. My volume starts to go up as my width goes up, but if my width gets too big, then my other dimensions must be smaller, and because of that, when my width is about 15, my volume is going to be about 0. And you can see that right there. But I want to find this point. That's the relative maximum point. Because it's the maximum point. It's not the maximum point because it does go higher up here for the function, but it's the relative maximum point between these 2 points. So to find that, I'm going to go to second calculate. I'm going to move down to maximum, and it wants me to put in the left bound. So I'm going to move my cursor. I'm on the left arrow right here. I'm going to move my cursor to the left of the maximum point and press enter. Then I'm going to move my cursor to the right of that maximum point and press enter. I could guess, or I could just press enter again, and it's going to tell me that the maximum volume is 2,052 square inches, and that happens when my width is 8.93 inches. And so you can see right down here, my width is 8.9314 inches, and my maximum volume is going to be 2,052.2 cubic inches. So if you're making a bag, you can advertise that you have the largest carry-on bag for whatever airline this is, but you'd have to make sure that you make your width to be this so that you get your maximum volume of 2,052. And we can check to make sure that that's correct. If I let W be 8.9314 and I plug that in for this W and this W and this W, I'd get my length, I'd get my height, and I'd get my width, and I could multiply them together and I would get about 2,052 cubic inches. So that's how we do a problem like that. We can go over more of this when you come to class tomorrow, and we will see you then.